Okay.
Yes, I can.
All right. Now, when we're talking about events in Solidity, we are talking about a crucial aspect of smart contracts, Ethereum smart contracts. What event helps you to do in your smart contract is it helps you to communicate to external applications. Now, there are numerous scenarios where you would want to communicate with your front-end application. I believe we all know what front-end application means. That is your decentralized application. There are times where you want to communicate with applications, your decentralized application or your client. How can you do that? You make use of events. So events actually helps us to communicate to external applications. You would want probably when something is triggered in your smart contract, you want to communicate to your front end that okay, this is it. That's what events help us to do. Events are declared using the keyword of events within a Solidity contract. So you use the keyword events to declare your event. This is the syntax for your event declaration. When you want to create an event, you would use the keyword event first, just like how you name your function. And then afterwards, you give it a name, which you have as the event name. And inside of your event, you can now pass in the parameters. So whatever data you define as your parameter is going to be associated with the event. Now you can include various data types, unit, address, string, and more, custom structs and more. So just so you can pass these parameters also. So your application can have access to whatever parameter you define inside of it. When you declare your events, in functions, how do you invoke your function in your contract? You'd call it with your parentheses, right? That is with your brackets. That's how you call your function. Now, in terms of events, when you want to, I'm going to use the word invoke. It allows contracts to log and broadcast specific occurrences, providing transparency and enabling external systems to react to this event. So there are two steps involved. It involves declaring your event, and then the second step is emitting your event. So at any point where you want to emit that event, when we say the word emit, it means what? Can someone just give like a definition of emit in the real world sense? Yeah, emit. Huh? So yeah, to call for action. Yeah, we can use that. Yeah, meeting fire. Related. Yeah, I think yeah, in the real world sense, related. Yeah, I think that can stand for it. So basically, in Solidity, use emit right to relate events by using that keyword. But you just need to understand that whenever you want to communicate with your external application and you want to send a particular event to your external application that okay, this event just took place, you use the keyword emit. So we are going to see a graphical and practical aspect of it. So we would know how to work with it and how it works. All right. What are the significance of events? As I've said, they are an integral part of our decentralized applications as they enable decentralized systems to communicate effectively and transparently. When we talk about decentralized applications, what are the applications on the Web3? So just to know, events are integral part, and we would see how it actually works and why they are useful. Now, best practices for emitting events. Emit events with descriptive names and well-defined parameters to provide clear and meaningful information. By now, we should be familiar with this practice, even not just for events, for functions, for variables. You need to you need to give them descriptive names, names that once another developer or even a layman should be able to look at the name given and understands that this is what this is going to do. So learn to give descriptive names. The parameters should be well defined in order to provide clear and meaningful information. Now, second practice is you should emit events at crucial points in the contract execution flow to log important state changes or transaction outcomes. So you need to learn to emit events at crucial points. Now, when we talk about crucial points, probably a point in your smart contract where something important something important is there. So, for example, if you are building probably a bank system, when you want to transfer, when a transfer is being made, it's important that you log that particular action. And then so many instances and scenarios in our smart contract. But you just need to know that for crucial points in your contract execution flow, learn how to emit events. Why? It will help you to log important state changes. That is a change that happens to your state. It will help you to log that. And then also transaction outcomes. Probably scenarios where a transaction went through. The outcomes, you can log that. Another practice is that you should consider using indexed parameters for efficient events filtering and retrieval. So we would use, during the practical section, we're going to understand how this works. So that was all. It's actually a slide of just 5 pages, not much. So we're going to kick off with the practicals. We're not done. I'm moving that to the practical section right now. So we just need to understand that. All right, cool. The mic is yours now.
Gem, everyone. If you can hear my voice, just send an emoji. Okay, thank you very much, everyone. So this morning we'll be back tracing everything we've been learning so far. We try to um, revise it and try to also add events. So this morning we'll be building something very, very simple, something not too complex, something that we can all understand and replicate. So I'll be sharing my screen now, and you can see that there's code on is on our GitHub repo already, so you can check it out for better understanding of how events works. So now let me now share my screen. Okay. Okay, I'm doing that already. If you can see my screen, please signify. Yeah, King, you might want to stop sharing your screen. Okay. If you can see my screen, please send an emoji so that I can start. Okay. Okay, awesome. Yeah, King, you can stop sharing your screen so that you all know the drill already, right? Let's try to do something. Crowdfunding.sol. So what we want to do this morning is we want to build a crowdfunding smart contract. And what we want to do is that we want to enable people to deposit any amount towards a particular goal. So by doing this, we can ensure that we build a transparent system where people can track how much we are receiving by checking um, the progress. And we're going to be doing that in a very simple way. And one thing is that if you have been lost since the beginning of this week, like because we learned a lot of new concepts, this is another chance for you. So let me try to copy our boiler code. We already know the drill, but I don't want to waste much of our time. So the first thing is we need the license identifier. We need the pragma solidity, which states the version of solidity that we are using. Then the next thing is contracts. Contracts. Let me try to zoom in. Okay. Okay. So the first thing I will do now is I will name the contract crowd funding. So this is the name of the contract, and it is like this. So now someone asked the question yesterday that when writing a contract, what should we consider first? Is it the logic behind the contract, or we should just start coding? Then anytime we run into problem, then we start fixing it. So I answered that you need to know what you want to build first. So now let's now go with that approach. I feel like this is going to make everything more simpler. Now, for this smart contract, we are going to be needing different states. For this kind of smart contract I want to build, I have to define it in a very clear and simple way. The purpose of this smart contract, the purpose is to allow anyone, anywhere, to donate 1 ether or above. So you can donate 1 ether or above. Then another thing again about this contract is that it's going to the contract is going to stop receiving new donations once we get to our goal, or once we reach our goal. Once we reach our goal. So that's it. Okay. Once we reach our goal. So the next thing again about this contract is that only the admin can withdraw the fund. So that's another thing about this contract. Only the admin can withdraw the fund. Then another thing again about this smart contract is that admin can only withdraw if we reach our goal, or we reach the deadline, or we reached the deadline. So now we've been able to define the contract in a very um, specific way. So we know that the purpose of this contract is allow anyone anywhere to donate 1 ether or above. The contract is going to stop receiving new donations once we reach our goal. Only the admin can withdraw funds. Admin can only withdraw if we reach our goal or we reached a deadline. So if we reached our goal, we reached the deadline. So now that's the main purpose of this contract. And for us to do that, we need to first set the goal. So and the goal is a number. It's not like a string or byte or something. It's a number. So we need a number. We need u in 256. And the main reason we're using u in 256 is because we are receiving in ether, and ether is a very big number. It's 1 times 10 raised to the power 18. So that's a very big number. So we can just use 256. Now let's now say this is our goal. But one more thing is that we don't want to change our goal once we set it. So we can make it immutable. This immutable keyword is to ensure that we cannot change the goal once or it's just like a promise that we will not change the goal once we start the donation on the every other thing. Then the next thing is we need to have a way to keep track of how much we have received so far. So that one is going to be changed, it's going to be increasing. So it's not immutable. It's going to be you know, normal UN 256 variable, which is going to be mutable. It's not immutable, it's mutable. So there's a difference between immutable and mutable. Mutable can change, immutable cannot change. So now let's now say progress. So that's we have two things already, because we know we are going to need a way to track the goal. We are going to also need a way to check the progress. We also need a way to know the owner of the contract. We need to know the owner. So it's going to be address of the owner. So that's another thing we need to consider. The other thing do we need here, we don't need any other thing. We just need the purpose is to allow anyone anywhere to donate 1 ether or and above. Okay. So one thing is that before we start, we need a constructor, and the purpose of this constructor is to set the goal for us and also to set the owner. So we can create a constructor. So the purpose of the constructor is a function too. But the difference between a constructor and a function is that a constructor will only run one time, and that's when you are deploying the smart contract. You cannot run the constructor twice, it can only run it once. So that's just different, and it is a public um, method by default. So you don't need to put anything public or yeah, but you can make it payable, stuff like that. But don't worry, this is enough for now. The next thing is, how do we now set the goal? You can allow the deploy of the contract to set the goal, or you can hard code it. You can hard code by saying 10 ether. So that means 10 ether is your target. And also you can hard code it by putting the address of the owner here. But I'm not going to hard code it. I want to make it flexible. So whosoever deploy the contract can have access to tweak those parameters. So that's it. In 256, then you into address. Do you need the address of the owner again? I don't need it. I want to make sure that whosoever that deployed this contract becomes the owner automatically. So I can do something like this. That okay, oh, this owner here is equal to whosoever deployed the contract, which is message or sender. Then this goal here that is set by the user from off chain is equal to this goal. So it's going to like equate the two. So by doing that, we've been able to initialize the goal and also initialize the owner. So this is just a basic thing that we need to do before we continue. Please, I'm ready to take questions. Now, if you have any question, please ask me, because I'm sure that some people have questions regarding this constructor. Please feel free to unmute and ask your questions. If you are physical, you can ask for the mic and ask your question. Why do we need constructor? What is constructor? Is it important that you have a constructor? What are the advantages of hard coding over making it dynamic or stuff like that? So these are some of the questions I'm expecting. But if you have any other question, please you can unmute and ask or drop it in the message box. Any question? Okay, since there's no question, I can continue. So we need a function. So the function is called deposit, as it is specified that we need.
Sorry, sorry. There's a question. We're just trying to omit first. Can I
Oh,
proceed?
good morning.
Yes. Good morning, sir. The question is it a bad practice to hard coded the code?
The what?
Is it a bad practice to hard coded the goals, like
It's
putting
not,
that?
it's not a bad practice. It might even save you more gas, but just make it more flexible and dynamic so that whosoever is deploying a contract can have access to set those parameters. So that's it.
Okay. Thank you.
Yeah, thank you very much. Welcome. Okay, so next thing is deposit. So let's say we have deposit function, and this deposit is going to receive fund from off-chain, right? So we can make it external and payable. This external means that we can only call this function outside of this contract. We cannot call it inside this contract. Payable means that this function can receive ether. So when you call this function, you also send ether with it. That's the meaning. So let's now move a bit down. Then let's go and check the rules for deposits. Anyone anywhere can deposit, but they have to donate 1 ether or above. So you can donate, but it must be greater than 1 ether or above. So I will now ask someone to like unmute, and I'm going to ask someone randomly online. So let me check someone. Daniel, are you there? Unmute. Please tell us how we can achieve that particular goal of um, allowing anyone to donate 1 ether and above in our contract. What is the best? There are a lot of ways actually, but which one would you use? Dan, are you there? Daniel, are you there? Hello, Daniel. Are you there? Please unmute, or you can drop the answer in the message box. If you are unavailable, you can let us know so that we can move to the next person. Alade Jamiu, please unmute and tell us. Is Alade Jamiu there? Alade Jamiu, are you there? Okay. Yeah, who is available physically to unmute to tell us the answer?
Um, Probably an if statement.
Okay. Yeah. Okay.
And also, we are going to use require here.
Okay. You're both right, but one
So
thing
we
is
can
that the
we can
first
use an
answer is not complete.
yes to complete the if statement. So we can set it that message.value equals to a particular amount, else revert.
Yeah, awesome. That's correct. That's the correct answer. And but for me, I would go with require, which is easy and more straightforward to understand. So require that the message dot value is greater than or equal to 1 ether. So because we need one or more ether to um, you know donate. So that's one thing about this contract. And you can just say that okay, if it is less than 1 ether, then you can send a message that okay, you must send 1 ether or above. So yeah, so that's how it works basically, and you can see that the code is here. And this is not just enough. We still need to do one more thing. We need to keep track of the progress, because there's no way for us to keep track of the progress. We are receiving funds. It's going to the smart contract. How do we now keep track of it inside the smart contract? Is by having something like okay, progress plus is equal to message dot value. Please note that this is a shorthand version. This line 20 is a shorthand version of this. It's equivalent to this. See, it's equivalent to this progress plus message dot value. So it's the same. So, but this one seems a bit nicer and cleaner. So that's why we are going with this. So don't worry when you see something like this. It's just a shorthand version of the same thing. Yeah. Let's now move to the next thing. So with this, we are done with our donation, and everything is working perfectly. So next thing is let's have another function that can also help us to, because there's another rule, only the admin can withdraw. So who is the admin? Someone can unmute and answer that question, please. Campaign, are you there? You can unmute. Who is the admin in this case? Campaign, are you there? Please unmute and tell us the answer.
Can I?
Campaign, are you there? Yeah, if Campaign is not answering, then you can answer.
Okay, the owner is the admin of the project.
Yeah, correct. So in this case, the admin is the owner, which means that we have to have a check, like a check that is going to check who is trying to withdraw. So by doing that, you can have a function withdraw, right? Then when you want to withdraw, it's going to withdraw all the amount available in the contract. Or better still, you can try to be creative and let the admin specify how much they want to withdraw. So it's going to be externalized, and that's the only thing we need. It's not going to be payable because we are not receiving, we are withdrawing. So it's not going to be payable. And the next thing is that we are going to require that the message dot sender is equal to the owner here, which is the owner of the contract, which is very straightforward. And you can just do that and say owner is, sorry, you are not the owner. So that's going to like prevent someone else from withdrawing. Then there's another thing that says admin can only withdraw if we have reached our goal or reached a deadline. So, but so far in this contract, we didn't set any deadline. We didn't set any deadline at all. It's just normal contract, and there's nothing like deadline. So we have to find a way to set deadline. And for us to do that, we need an integer that's going to store something we call a timestamp. I know you guys, this is not the first time you'll be hearing timestamp. We did something earlier and discussed that okay, there's something called timestamp, and we can just have something like this that okay, you in 256, the deadline is equal to block dot timestamp plus 3 days. This kind of scenario now, we are saying that okay, the deadline is 3 days from now. The current time that we have, which is the time on the blockchain plus 3 days, you can do plus 1 day, you can do plus 1 second, you can do plus 1 hour, you can do plus 1 day, you can do is there months? There's no months, you can just do this. So and so on and so forth. So now in this kind of scenario, we can't wait for like a day. We can't wait for 1 hour. We just need to go with a very small time, just for the sake of testing. You can just say 5 minutes, which is awesome. Then the next thing is that what if this is just hard coding, right? We hard coded the value. This is an hard coded value. You should also find a way to maybe make this thing dynamic. Whenever the admin is setting this thing, they should you know set it from this place. So you can just come here and say that okay, admin can do something like this, maybe like in 256 deadline. So this deadline is going to be in numerical format, and you can now say deadline is equal to the deadline provided by the admin. And once you do something like this, you have to go and get the timestamp of your deadline online, which I can do by just doing a very simple Google search. Let me do deadline, generate timestamp, sorry, generate timestamp online. So if I do that, I will be able to get different tools that can help me to generate any timestamp that I want. Let's wait a minute. Trying to verify if I'm with bots. Okay, so you can see that we have different parameters that we can set. We have year, we have time, we have. So if I click on this, let me try to generate timestamp for tomorrow by 10. 10. Let me try to change it to 10 something. 10 o'clock. Then you can change the time zone. The time zone we use in Nigeria is GMT plus 1. So you can use the time zone. Be cautious about the time zone that you choose so that you will not run into problems. Because by choosing another time zone, it's going to affect the so take note. So now once I submit, I will be able to generate the timestamp, which is something very similar to this. You can see that I've gotten a timestamp and it's 1706263200, which is this timestamp, and it is in number. So that's why we are using number for our deadline. So something like this can just pass it to your contract, and from there you're able to set your contract. You will set your deadline in your contract, and that works perfectly. Now let's move on to the next thing. Since we have a deadline, right? We can. I told you there are different ways we can do this. We can either hard code it or set it manually. So we are not hard coding; we are setting it manually. You can also require that. You see, there's a problem with this one. Now, let me show you the first problem I run into with require. Let's say require that the progress is greater than or equal to the goal. So now, this condition is very simple in the sense that let's assume that our goal is 1,000 and we are at 900. What does that mean? Does it mean goal is greater than progress, or progress is greater than goal? Can someone unmute and give us the answer, please? Which one is greater? Is it the progress or the goal as of this moment? I want someone online. So I'll be calling someone, please. Once I call you, please unmute immediately, please, because of our time. Trust, are you there? Please unmute. Trust, are you there? Trust, are you there? Okay, I think Trust is not with us this morning. So, yeah. Okay, let's move forward. Let me check someone. Rashidat, are you there? You can unmute. Rashidat, you can unmute. Okay, Rashidat is not with us. Adewale, are you there? Adewale, are you there? Okay, you are here, Rashidat. Okay, what's the answer? You can just type it out. Which one is? Okay, we can unmute. Sorry. Oh, sorry. Admin actually, I restricted you guys from turning on your mic. Okay. Yeah, you can unmute now. I give you guys access. Which one is greater? Is it the progress or the goal as of this moment? Progress is 900 and the goal is 1,000.
Because it's greater.
Okay. So at this point, do you think the contract will still receive donation or it will stop receiving donations? Hello? At this point, do you think the contract will keep receiving donation or stop receiving donations? Yeah, campaign, you can unmute. You can answer the question. Okay, receive donation. Yeah, awesome. Adewale. So that's correct. At this point, the contract will still receive donation because the progress is still less than the goal. So one thing about this requires that anything you put here is your desired state. It's like what I want my contract to do. So what do we want our contract to do? We want our progress to always be lesser than or equal to the goal. So that's our desired state every time in this contract, that okay, the progress that we have made must be lesser than or equal to the goal. If it is greater than the goal, then it is not a desired state, it should fail. So that's one thing you have to know about require. always put your desired state here. Our desired state is that the message.sender is equal to the owner. So that's our desired state. Our desired state is that message.value must be greater than 1 ether. So that's one thing about this require, and it's very, very easy to use. And that's why I said there are some concepts that we talked about this week. They are just theoretical or too complex to understand, and they might seem discouraging, but you need to know them because who knows, you might need them anytime, and just trying to like Google them. There's a difference between knowing that okay something exists but you don't know how to use it, and you don't even know that that thing exists, and also you don't know how to use it. That one is far, far, far more difficult because once you know that okay, this thing is actually possible, then the next thing is how to do it. It's going to be far, far more easier. So that's why. And honestly, like if you have been following us from day one, and you can see that we are progressing, and we are progressing gradually. And by the time we are done with next week class, we'll be fully done with Solidity, and you guys can really brag that you know what Solidity is all about, and you can write smart contracts confidently. Okay, so let's now move forward. That okay, the progress is less than goal, or you should just write an error message that okay, goal reached. Goal reached. Thank you. So that's just now. How do we now know that this our condition is valid? Can someone tell me what's wrong with this condition, this withdrawal? Whosoever gets it is we are doing a giveaway of sticker, so you can pick up a sticker for free. So if you know the answer, please raise up your hand and unmute. Oh, trust. We're very sorry about that. The network is bad. So there's something wrong about this line of code. So if you can tell us the answer, you are getting a free sticker. So let's hear from you guys. There's something wrong with this line of code. What was it? In this withdrawal, check this condition. Your admin can only withdraw if we reach our goal or reach a deadline. So there's something wrong with this code in particular.
I think it's because there is less than equals to the goal. Less than or equals to the goal. It's not even
Okay, it
reachable.
must be less than equal to go, right?
Yes, I think that's the problem.
Sorry, can you repeat that? Sorry.
The admin can only withdraw if we reach our goal. But in the code, you said less than or equals to the goal. Okay, yeah. Sorry.
Yeah, that's correct. Actually, you are correct. A round of applause, please. That's correct, actually, because according to the logic we have here, we must exit our goal before the admin can withdraw. So we have to see that goal um, must be like the progress must be greater than or equal to the goal, right? So that's just the unlike the one we have before, which is less than or equal to goal, it must be that the goal must be greater than or equal to. So the progress must be greater than or equal to the goal. So now let's assume that we have something like this again. Let's say we are at 999, and the admin is trying to withdraw while the goal is 1000. It's going to fail because we've not reached our goal, and because 999 is not greater than or equal to 1000, so it's going to fail. So the moment we reach 1000 and admin tries to withdraw, it's going to now be 1000 is greater than or equal to goal, which is true. Then it will go successfully. So that's the only problem we have with this smart contract. We
What
have to
of
fix
if
it.
it is 1,200 or something? Would this still go?
Yeah, it will go because see, 1200 is greater than or equal to 1000. Can you see it is true? It's true mathematically. Like
Hello, hello.
1200 greater than or equal to 1000. Yeah, someone is talking. Okay, so let's continue. So the next thing now is that we can also add another line that require that the block dot timestamp is greater than The block the timestamp, which is the current time, is greater than the deadline. What does that mean? Let me do a very simple example. Let me put the error message here. So the very simple example is that the timestamp keeps increasing second by second, so it keeps increasing. And one thing is that let's use 2003 and 2004 as an example. 2003, let's say our timestamp is 2003, which is our current time, and our deadline is 2004. Do you think that this code will run? Our timestamp is 2003, but the deadline is 2004.
Sorry,
Will
hello.
this, yeah, are you with me? Hello? You can unmute. Yeah, you can
Okay, sorry,
unmute.
I wanted to confirm something before I get further lost.
Okay.
The require, is it like it's working like an if statement? Like if this condition is true, that's when you do this, or I'm trying to like get
Okay,
why.
it's a combination of two things. It checks and also throw error. So it checks your condition for you. Then if that condition is not true, it throws an error. So look at this code that I want to
It takes
write.
two arguments.
Yeah, it takes two arguments, which is the condition and the error message. Do you get?
Okay.
So now it's
Okay.
equivalent to this. See, this code here, right, is equivalent to this. See,
Sorry, your screen is like blank in my face. It's like as if it's hanged or
oh,
something. I'm not seeing
the
anything.
network. It's
Oh,
a
my network.
network. Yeah, you can try to rejoin. So the code is equivalent to what I'm trying to do now. You can, let me say revert. Then you have something like this. So this code, this line, this single line of code is equivalent to this. And which one is better? Can someone tell us which one is better?
Oh, it is like this.
Yeah, this reverse is equivalent to this. It's like a shorthand. It's more cleaner and is, just too easy to use. Yeah. Do you get it now?
Okay, yes, I get it.
So that's it. And so these are desired condition. If desired condition is not true, then it will now throw this error. So that's how require works basically. So the next thing now is for you to now learn about um, this combining two conditions together. So this thing is going to serve as and now because first our logic is or. See, there's or here. If we reach our goal or we reach a deadline, meaning this is like a campaign, right? It's a campaign, and we don't know how successful this campaign is going to be. We don't know how successful this campaign is going to be. This campaign, we might not reach, we might never reach our goal with this campaign, and we might exceed it. Just to be on the safer side, we are trying to do that. Okay, even if we don't reach our goal and we reach the deadline, we should still be able to withdraw our funds. But with this kind of logic that we have, is and we must reach our goal and we must also reach our deadline for this contract to execute. Because for this function to execute successfully, see, you have a progress is greater than or equal to goal. Progress is greater than or equal to goal. And block.timestamp must be greater than deadline. So this condition must be true. This condition must be true for the contract to execute successfully. And that's not what we desire. We desire that either of them must be true. Is that this one is true or this one is true? Either of them must be true. This one is true or this one is true. If any of them is true, then we can easily do something like this. Or so you can say or. So is either the progress is greater than the goal or the block timestamp is greater than the deadline. So that's one thing you have to know about this part of the code. And once we are done with that, we now have to like consider the owner.transfer, but it will not work. We run into error, I'm very sure, because let's do something like address this dot balance. So you can just make the code neater. You can declare a variable inside this function, name it u256 balance. Then say balance is equal to the balance of this address. So just make it neater. Then you now put the balance here. We are getting an error here. Why are we getting that error? Can someone unmute and tell us why we are getting this particular error? Someone should please unmute and tell us why we are getting this error. Let me call someone. Precious, are you there? Precious, are you there? Why are we getting that error? Okay, Precious is not available. Someone else can take it from physical class.
Hello, sir.
Yeah, good morning. Hello.
I think we need to make the owner payable. We need to add payable
Yeah,
to the owner
we are
to be
doing
able to.
an implicit conversion, which is not possible from uh, address to address payable. So we need to just say payable owner, which will solve the problem, and we are good to go. Is this working? Okay, what's this? Let's check. Let's backtrace. Yeah. Oh, sorry. We need to close it. We need to add semicolon here. So that's we are done. We are good. So these are our contracts, and this is a very simple contract that will enable you to do your crowdfunding. This is how to write a smart contract, and it's very simple and straightforward this time around. And we spend less than 30 minutes, or yeah, around 30 minutes on this contract in total. So what we can do now is just try to deploy it. If I come here, I can set the goal. Let me set the goal to 2 ether. There's a website that I use regularly, convert way to ether. So it's a website that can really help you to convert ETH converter. So now if you have 1 ether, I mean let's say our goal is 10 ether. So how do we convert it to way? By using Ethereum unit converter. So we can this 10 ether in way. So we can just come here, put the goal, then the deadline, go back to our timestamp guy, then we generate a timestamp for the next how many minutes? What's today's date? This 25. Let's say 25. Then let's say 10:55. Let's say 11 o'clock. 11 GMT plus 1. That's my time zone. I'm in Nigeria, so you can see that. Okay. So this is the timestamp for 11 o'clock, which is the next 5 minutes. Yeah, basically. So just put it and transact, and we are good to go. We have a contract, uh, a deployed contract. Then the next thing is the deposit and withdraw. Let's try to deposit. Let's try to deposit 1 GUI. 1 GUI is not up to 1 ether. So if you try to deposit, it's going to show error. You can see that there's an error. You must send 1 ether or above. The contract is failing at this point, which shows that it is working perfectly. The next thing we can do is let's go and change it to 1 ether. So we have 1 ether, and we can come here and say deposit. It's going through, and you can see that we have 1 ether. If you try to withdraw, we are going to get error that go reach thank you. That's actually we added the wrong message, so but don't worry, it's failing. Let's try to now do something. We can either wait till 11 o'clock, or try to reach our goal by asking more people to deposit. See, deposits. More people deposited. So we have 10 ether now, which is greater than or equal to our goal. If you click on withdraw, we've been able to withdraw and it is successful. So that's how to do basic checking and checking your smart contract. But if you notice one thing, it's very easy for you to make mistake, especially when it comes to timestamp. We can come here in our contract and add more conditions that this timestamp require that this deadline that we are setting.
Good morning, sir.
Yeah, good morning.
Sir, before you go further, sir, I would want you to please return those statements you commented. So
Statements.
the statements we wrote down before we started the coding.
Oh, sorry, I deleted them.
Yes, sir.
Can I undo?
Yeah. Yeah, just undo you.
Okay.
Yes,
Do you
sir.
want to, do you want to get them?
No, it's okay like this, sir.
Okay.
Sir.
So you have it. So in case you want to rewatch the video, you can easily get it back.
Yes, sir.
Okay, so just grab stamps. Let me try to undo. So let me undo again. Okay, let me cut. Okay. Okay, we're good now. So let me try to put it outside the contract. Now the next thing is we want to add a required statement that checks whether the deadline has been exceeded or not. You can say deadline. This deadline that we are setting must be in the future, not in the past. So the deadline must be in the future. You can say block dot timestamp must be less than this deadline, or better still, for you to understand better, let's invert the logic. Deadline must be greater than block dot timestamp. So you see that this deadline that we are setting must be greater than this block dot timestamp, else it will fail. The date is in the past, or something, or the timestamp is in the past. We can just have something like that. So let's try to now or continue what we're doing, because I have a timestamp here with me. It's for let me show you the timestamp. It's for 11 o'clock, and we are just 1 minute away from 11 o'clock. So let's just wait before we experiment with that timestamp and see the effect. So we are just about 30 seconds away. So now let's try to do something again. We also need to consider that what if the timestamp is too far in the future? Like we don't want to set a timestamp that is in 2000, like 2050, 2060. It's too far. And it might just make a mistake and you are not checking. Maybe even the website you use there might be error, and from there you will make a mistake and deploy a contract, and from there you lock your funds forever. So to just ensure that we don't run into that, we can also run a check here before you allow your constructor to execute. So let's now go back to our deploy and run transaction tab. Let's set our goal. Oh, sorry, our goal is to, let's just set a simple goal, maybe like something simple. Then let's put the deadline. The deadline is in the past now because that's like 1 second ago. You see that it failed already. You can see the timestamp is in the past. But if I change the timestamp and add something like 900 and I try to transact, you can see that it's working now because I changed the timestamp to the future. So that's how to check, and you can also compare timestamp. So also to prevent our distance from locking, you can say require that block dot timestamp is less than sorry, it's not block dot timestamp, it should be deadline. The deadline we are using must be less than block dot timestamp plus maybe 10 days or 50 days or 20 days, depending on how many days you want to raise your funds, or maybe like 7 days on fundraising campaign or 30 days fundraising campaign. So that's like 30 days. So you cannot choose a date that is in the past or greater than 30 days. So let's prove this by going back to our contract tab, contract deploy and run transaction tab. So one thing is that we can go back to this timestamp generator. Let's try to generate somewhere around May, which is like let's try to use somewhere around March, which is more than 30 days away. Let's say submit. If you generated the timestamp and you see that it's in the future, okay, where is the timestamp? Yeah, this is it here. The timestamp is in the future, and we can just come back here and try to put it in our deadline. Let's put a goal and transact. Once you transact, you will see an error, but let's try to check the error. Goal, deadline, transact. The transaction has been reverted, blah, 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 blah. It should be less than your current balance or something. Yeah, it's reverting because we didn't put an error message. So we cannot know the error. You see, it's just reverting. It's not showing us any error message. We didn't put any message. The timestamp is to let me just the timestamp is um is is above 30 days 30 is above 30 days limit or stuff like that. It's above the 30 days limit. Okay. So yeah, we are just a very simple raw message that can enable us to understand what we are building. So now let's now try to put that same timestamp again. The goal and let's transact. You see that it's showing error that the timestamp is above 30 days limit here. You can see the error here. You can see the error here. So that's how to check. And with this kind of checking, it can save you a lot of stress when it comes to like maybe migrating your contract when you run into problems like that. Then let's try to generate a date that is not too far. Maybe like in February. Let me say February 14 or something. Let me just submit. Let's change the timestamp for February 14. So we have the timestamp already. And let's come back and try to put that one there. Transact. You can see that that one is working because it's like lesser than 30 days. That's how to do checking, and you are good to go with checking. And this applies to every other thing when you want to do your smart contract. When you are dealing with time, you have to be cautious of how you write your code. The next thing is let's try to now add events. What are events? Events are like when you call a function, you call it right. You have to be the one to trigger it. But events are emitted from the smart contract when when there's an action. Maybe someone tried to like deposit. The smart contract is going to emit an event. Then your application can now listen to it. Your app can listen to it and know someone deposited on your smart contract. Go and check. Someone deposited on your smart contract. Go and check. That's how it is possible for you to receive notification when maybe someone sent you funds in your MetaMask or stuff like that. They combine events and stuff like that to notify you. So that's it. And for you to now enable your smart contract to support it, you have to do something like this event, give it a name, and something very easy to remember, and also like something very nice. You can say deposit or something, deposited or something. Yeah, yeah, deposited. Yeah. So now this is a very simple event, and it is okay like this. Without any parameter, you can have an event and come to anywhere you want to emit. Just say emit deposited. So it's going to be pretty straightforward, and you can just do like this. And anytime you call on deposit, it's going to emit the event. But what's the essence of emitting an event when you don't really give more information about the kind of event you are emitting? Maybe you want to talk about who deposited the funds, how much did they deposit and stuff like that, so that your application can listen to it. So anytime your application receive any deposited events, it's going to get two parameters like who deposited and how much they deposit into the smart contract. So to do that, you can say address depositor. You can name it anything you want. In fact, you can even remove this address if you don't want. So just do this. So deposited in 256 amount. So you can do stuff like that. And now this event is now asking for two parameters now. So you have to just two arguments. So you can just put the message dot sender comma with the amount they deposited, which is message dot value. So I'm going to emit this event, and it's going to be received off chain. So now let's try to deploy this contract again. You can even set your distance to check your goal, maybe your goal is reasonable or not. So you can also have another condition here that says, okay, maybe because the minimum someone can donate is 1 liter, right? So we have to require that the goal that we are setting must be greater than or equal to 1 liter. So if it's lesser, it's not going to work to prevent your contract from run into problems. So you can say you cannot set a goal below 1 ether. Do you get? So this is how it works basically, and you can have the goal here. Then let's have the deadline. Let's go and check a deadline. I've copied the deadline from this timestamp website. Let me transact. You can see that you are getting an error that you cannot set a goal below 1 ether. So we need to check, make sure that these things are above 1 ether. Let's transact. It's still below 1 ether. Let's keep adding more values. It's still below 1 ether. But 1 ether is a very big number, you see. So it's still below 1 ether. So let's keep adding zeros. Is our logic correct? Oh, yeah, we've reached 1 ether. So it's working perfectly now. So the next thing is we added a logic to this, we added an event to this deposit. And one thing you have to notice that you cannot declare an event inside a function like this. See, you cannot deploy it inside, you cannot declare it, it's not work. You have to declare it outside the function, inside the contract. So, but when you want to emit it, you can emit it inside the function, but you cannot emit it outside the function. So that's just the difference between emitting and declaring an event. So now we have the contract ready. Let me close the former contract. Oh, let's try to deploy again. Now I have the contract ready, right? So let's try to deposit. It's failing because we didn't send 1 ether. So let me go and send 1 ether. Once I send 1 ether deposit, you can see that it's working, and we have a lot of parameters, a lot of information on our console. So let's try to check through the console. You can see there's something called logs. That's where you retrieve all the events from. So from that, you can see that there's something called event here. Let me try to zoom in, please. Oh, it's too big. Okay, so we have this log. Then under this log, scroll down, you can see there's event. Another event we have deposited. Then the argument is this. And how much did they deposit? 1 ether. So that's how it works basically. So from using this, you can receive event off chain and listen to it in your front end application. That's beyond the scope of this class, but just so that you can emit events from your smart contract, and that's how to read it. Let's try to now do indexed events so that we can understand how index works. And let's say indexed. What's this? We're getting an error. Okay, sorry. Is it meant to be like this? Yeah, it's meant to be like this. Sorry. Address index depositor. So now you see that I want to show you the difference between using an indexed event and indexed parameter and the one without index. Now let's go back to this contract. Let's try to deploy again. Let's set my go to 1 ether. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. I know it's more than that already. So the deadline should be somewhere in the future. So let me get the timestamp. So let me get the timestamp and transact. So I've transacted, and what I can check this. You can see that in the first transaction we made, which is the deployment transaction, there is nothing like log. The log is empty because we did not emit any event. But when we now deposit, let's try to deposit. Let me come here and deposit 1 ether. Deposit. So you can see I've deposited 1 ether, right? And it's showing me a message, which is a success message. I can just scroll down and check different values that I have here inside my log. You check this log, you can see that there's event and there's deposited. There's where is it coming from? The contract address. That's the from. The topic is like you know the when you are working with WebSocket and you get topic, so you want to listen to a particular topic, which is the hash of the event. So now the next thing is the event name deposited. The argument we have 0, 1, and we have depositor. So you notice that unlike before, let's scroll up. let's scroll up to the former event we had here. So you can see that there's nothing like let me scroll down. I'm coming. Oh. Okay, there's actually something like a depositor. Let me check. Oops. Okay, so yeah, sorry, my bad. One thing is that you can use this index. You can now filter this your event according to this depositor. Now you can filter it off chain. Like there's a way you can use Web3.js or EtherJS to do that. So when you listen for events, you can say, okay, I don't want to listen for any other event apart from deposit, and when the depositor is this particular address. So that's one of the things you can use this index to do, and it's going to be like really, really helpful when we start building applications. So please, I'm going to open the class up for interaction and questions. We have a lot of time today to take as much questions as possible. So please, if there's anything you want me to code for you, like in particular, you can ask me to write it, and I will do that in this class. So yeah, let's get started. Yeah, who's coming first? Yeah, who's coming first? Who's coming first? Okay, it seems no one is having any problem with their code, right? Please feel free to ask questions. Maybe question. I think one of the most difficult things to understand is mapping and structure. Yeah. So far in this week, and also that function selector. But one thing about function selector is that except you are building something very
Hello,
complex.
sir.
Yeah, I'm with you. Good morning.
Okay, sir. Since we have some time, can we? Good morning, sir. Since we have some time, can we quickly do that thrift contract? Can you give us an idea of how it works?
Okay, so I won't be doing the
I'm
truth.
just getting to know that thrift means
I won't be
ajo.
I won't be showing you how to do the truth contract. And the reason is because it's an assignment, and it's the most important assignment of this
No,
week.
just an idea.
Okay, it works the same way we did the donation, but this time around, you need a mapping that will now log of each person's donation. Do you get each person's contribution? So when you want to withdraw,
Okay.
when you now want to withdraw, it's now going to require that, okay, require that the
Can we
amount this person is trying to withdraw.
can we have an illustration?
Okay, let me so let's come back to our code, and let's have a new file. So let's name it 18 underscore thrift dot sol. So now let's copy our boilerplate. So this is the boilerplate. I'm coming. Thrift. So yeah, we have the boilerplate already. Now let's name thrift Abby. So this thrift contract is very simple, and what you need is the principle of a thrift is that, okay, anyone can contribute. That's the function. So you need a mapping for that. Anyone can contribute. Um, your progress, anyone can contribute. You should be able to see your progress. Then there are some treats that, okay, you have to reach a particular milestone or target before you can withdraw. But if you don't want to make it like that, you can just go with the simple one. Okay, you can withdraw anytime. You can withdraw anytime, right? So also you can also move forward and say you can only withdraw your contribution. So now let's say for this one now you have a mapping of each person, the mapping of address to contributor. That contributor can be like a struct, or you can make it just normal number. So mapping of address to number. Then when you deposit, is going to go to your index and increment it by the amount you deposited. If you deposited $1, it's going to say plus one for your address, plus two, plus three, plus four. Then when you want to withdraw, it's now going to check if your index of the mapping is going to check the balance. If the balance is greater than how much you want to withdraw, it's going to allow you to withdraw. Else, it's going to throw an error. Then once you withdraw, it's going to remove your, it's going to reset, it's going to remove the amount you withdraw from your balance. So that's how it's going to work basically. And from there, I believe you should be able to like understand how to build this thrift contract. So that's how it works basically. I hope I've been able to answer your question. Hello? Yeah, hello.
Hello, sir.
Yeah, I'm with you.
Hello, sir.
Yeah, I'm with you. I'm with you.
Yeah. So that means that I'm also going to include the logic that will mean that I can't withdraw above my current balance.
Yeah, sure. Your current contribution.
Okay.
Yeah.
Okay. So we are going to do it in a way that mapping will mean that since different people can withdraw, we have to do it in such a way that they can only well, this thing go hard small.
It's not actually hard. We've done most of it already. It's just like for you to change the code to treat contract. The donation contract is exactly the same way the treat works. The donation contract. Let me just show you the donation contract. The crowdfunding contract. The same way. See all this deposit. Like here now, instead of having progress, you can just have the index of each person plus or equal to the value. Like maybe contributors, open bracket, message or sender plus equal to value. That's it. Then when you want to withdraw, instead of checking that, okay, who is withdrawing, you don't need to check this owner withdraw again. You can just check that, okay, the index of the contributor, is it greater than the amount the person is trying to withdraw? And that's all. Then, remove the amount to withdraw from your deposit, which is like reverse of this line 28. So that's how it works basically. And I've even given you the full this thing, the explanation already. So just for you to work on it and get it started. Yeah. Any other question from anyone? Actually, that question is like asking me to give you the answer to the assignment. I won't do that. So if you have any other code that you want us to write, we can do that. We still have
I'm sorry, can you please take us back to the thrift contract statements?
the what?
The thrift contract statements.
The truth contract statement.
Yeah, the ones you wrote earlier.
Do you mean the
Thank you.
instructions, right?
Yeah,
Do you-
this is it. Thank you.
okay, so you can actually formulate your own. It doesn't have to be this. You have to like be the one to like think of what you want to build and write it out, like maybe in 4 or 5 steps. So then it doesn't have to be this one. It can be anything you want. Just make sure that it's unique. Daniel, welcome back. Are you back? If you have any problem, you can unmute and share with us so that we can solve it together. If you have any problem, please unmute.
No,
Yeah, good
no,
morning.
there's no problem for now.
So
Yeah,
okay.
good morning.
So
There's no problem for now.
you've been submitting assignments, right?
Yes, I've been submitting that of last week. Just this week, I've not submitted because
Okay,
of
when should we be
coincidence.
expecting that?
Possibly from tomorrow, I'll be submitting on for this week.
Okay, that's awesome. Thank you very much.
Okay.
So what's the most difficult part of this training? Is it the struct? Is it the function selector? Is it what's the most difficult part? Adewale Ryan, you can unmute and tell us.
Hello.
Hi.
So I want to talk about the function selector. It's really kind of so. What I want to say about it is, how are we going to go about it? Is it only on the byte section or the address section? Because I can't understand the byte selector, the function selector.
Okay, so have you gone through the code? So the principle of
And that
function
KCAC
selector,
256.
okay, KECAC 256 is just hashing algorithm, something like what we did on the first day. So one thing is that KECAC 256 is just like what we did on the first day, the MD5 we did on the first day. We showed how you guys can hash stuff. So another way of hashing is using KECAC 256. So that's one thing. Then another thing about the function selector is that function selector allows you to call a particular method on a particular address. So, but the function selector is like a unique identifier for each function. For each function signature. Let me say function signature in the smart contract. So when you have a smart contract now with different function like deposit, withdraw, and stuff like that, and you want to call it from another smart contract, you don't want to go the normal route. You can just say that, okay, address dot call, then maybe like ABI dot encode with selector, then put the selector byte, then pass all the parameter and call it, just like saying uh, token dot transfer, which is like, the token will be the contract and the transfer will be the method. But you don't want to call that, you can say uh, address of the token dot call, then put the ABI dot encode with selector, then the selector for the transfer, then the parameters that you want to use to transfer, and that's how the function selectors work. But don't worry, you can still do without function selector, and you'll be fine for now. So as not to get things complex, instead of focusing more on function selectors, try and focus more on structures for now that can really help you, understand how Solidity works better. Focus more on structure and mapping for now. So yeah. Any other question? Okay, thank you. Since there's no other question, we can call it so that people watching this video can get it in. I think you represent everyone who joined physically, and then they might. Okay, yeah. Thank you.